Okay, now on to the last questions. We have the left side here, which wants us to solve this trigonometry equation where you have two factors that are equal to 0. And so basically, you could think of this as something times something equals 0. And the only way this is true is that either A is equal to 0, so A is equal to 0, or B is equal to 0. So that's basically how we're going to solve this. So we're going to say for this first factor of 2 cosine minus 1, we're going to say, like, let's just let 2 cosine of theta minus 1 equals 0 and see what's the value of theta that gives us this answer. So I move the 1 to the other side. I'll get 2 cosine theta equals 1, and then divide both sides by 2. I'll have cosine theta equals a half. And now I'm asking myself, what is the value of theta that gives me a half? And so if you recall, this is actually a special triangle. If you go down to your special triangles, here it is on the second triangle, this one here. Here we have a half, and so the half comes from the 1 here and the 2 here. So that's using this angle 60, because cosine is adjacent, so this side here divided by my hypotenuse. So cosine of 60 degrees is equal to 1 divided by 2, which is exactly what I want. So in other words, theta is equal to 60 degrees, but they ask for the answer in terms of radians. So if you recall, 60 degrees, and you want to change it to radians, you divide by degrees and multiply by radians, so that these basically cancel out. We have no more degrees, and this would give you pi divided by 3 radians. So yeah, that's the first one. However, we should quickly also check something, which is if there's any possible other solutions. So I'll quickly draw something like here. Sorry, it's 3 pi over 2, and then 2 pi. And we're just going to check something called the cast rule. And because our answers, we're only looking for answers that are between 0 and pi, so that's going to be in this top part here. So from 0 to pi, you want to find where is cosine positive, because we saw cosine is equal to positive of a half. We said our first answer is at pi over 3, which should be here somewhere, like roughly speaking, because this whole rotation is pi. And so if we can cut this into thirds, basically, here's pi over 3. From here to here would also be another pi over 3, and then from here to here is another pi over 3. So point is, here is my first answer. And this A stands for all, C stands for cosine, T stands for tangent, and S stands for sine. And these are telling you all the places where that shown trigonometric function is positive. So cosine is positive only in this first quadrant. So this is my only answer. So only up here in this first quadrant, because A stands for all trigonometric functions, is where cosine's positive. And so this is my only answer. And so I'm going to actually keep this image that we have. I'm going to pull it aside so that we could use it again. And then we'll solve in the meantime for the second factor that we have here. So we have one answer there. And then we're going to check the next one. So if this is true, we can say that we can let cosine theta plus 2 equals 0, because again, we're multiplying two things. And either the first one has to be 0 or the second one has to be 0. So we're just checking both. When we check this one though, cosine of theta be equal to -2. And for this one, we don't actually have any answer, so there's no solution. And the reason why is because if you recall, when you're drawing a cosine or sine graph, they both are never going to be anything that's bigger than 1 or negative 1. So 1's down there, negative 1's down there. And it's basically asking when is the value of theta that you get um, negative 2. And then you can say, well, there's no value, anything here, there's none of them, makes cosine go down here to negative 2. So there's no solution here for the second one. So that means for our first part of part C here, the only answer is pi over 3. So that's the first one done. We can just erase these things and then move on to the last one. So in this next one here, we're looking for something and it equals 0 again. And we're looking at the same area. So only looking or concerned with this first part here. So I'll just leave this like this. It's cast rule, so spelling cast there. But in this one, they don't have it already factored for us because it was kind of easy. We can, if we started with it factored, I can just say, hey, this has to be equal to 0, this has to be equal to 0, and then find what's the value of theta. We're going to do that again, but we have to first factor this because there's a common factor to both, which is sine. So the first thing we can do is we can factor out the sine theta, and then we'll have 2 cosine squared theta minus 1 equals 0. And just like we said before, both of these terms or factors must be equal to 0, the first or the second. So if we're checking the first one, sine theta has to be equal to 0. And then there's no triangle that you can find that will give you the answer here. So we're going to use a unit circle as like a reminder if you don't remember what it is that makes sine of theta equal to 0. So you can also check this. So there's 1, there's the point, there's 0, 1, I'll say like this. It's 1, 0. This is the point 0, 1. This is the point negative 1, 0. This is the point 0, negative 1. And so sine is wherever our y value is equal to 0. So here, here is where we're equal to 0. And here is where we're equal to 0. So my two answers is going to be going back here. Like, what's this rotation that gets me to here as well as 0? So my first answer, I could say theta is equal to 0. That's my first, or 0 degrees or 0, 0 radians. And then my second one is over here. So these are the two spots where sine is equal to 0. And this second one, if we go back just to this image here that we already made, would be at pi radians. So my two answers are for this first factor is going to be 0 and then also pi. And now I'm going to check the second factor and see what are the values that make this theta equal, this whole factor rather, equal to 0. So I'll say, again, we can just let this whole thing equal 0 and then solve for theta. So I'm going to move the 1 to the other side. This is like we did before. And then I divide both sides by 2. And then cosine squared theta is going to be a half. So I can take the square root of both sides, and I'll say that cosine has to be equal to plus or minus, because we take the square root of a square, the square root of 1 over 2. And this is saying the same thing as the square root of the top number and the square root of the bottom number. And the square root of 1 is just 1. So it's just going to be plus or minus 1 over the square root of 2. And this, again, is a special triangle that you might be familiar with. And it's down here. So here is where I have 1 and square root of 2. And so I'm asking myself, what's the value of cosine gives me 1 over square root of 2. And so that's, again, adjacent for cosine divided by hypotenuse. And so if I consider this angle, my adjacent is here, which is going to be 1 divided by the hypotenuse, square root of 2. So that means theta has to be 45 degrees. But in our question, it doesn't ask for degrees, it asks for radians. So just like what we have here, we have to change our answer from 45 degrees to to radians. So we take our answer of 45 degrees, and I don't want degrees, so I'm going to make sure they cancel out and leave pi on the top. And then if you put this into your calculator or simplify 45 over 180, this is going to be just pi over 4. So that's our first answer for the second factor. So theta is equal to pi over 4. And then we need to look and see, hey, wait a second. We have two answers here. The positive and where cosine is positive and where cosine is negative. And so when we look up here, cosine is positive only in the first quadrant because all of the trig identities are positive. And so that's going to be my first answer here. Pi divided by 4. And then we say, is there anywhere on this where cosine is negative? And we would say yes, cosine would also be negative in this second quadrant because only sine is positive here. Only sine. So in other words, cosine must be negative here. So what I do is I say, this is the angle that I got. And so I'm going to always, this is called also a reference angle because, or what we found is our reference angle, pi over 4. And that just means whatever the angle is made between here and the x-axis. So this is pi over 4 as well. And so now we say how far from 0 do we have to go to get to here? And so it would be a whole pi radians, and then we subtract pi over 4 radians to get that second answer. So my second answer will be theta is equal to pi minus pi over 4 radians. And then pi I can just write as a common denominator as 4 over 4. So I get 3 pi over 4 as my second answer. And so this is our final answer. So all of our solutions, just writing them out, theta can be equal to 0, pi, and from our second one, pi over 4, or 3 pi over 4. So those are our total list of solutions for theta between 0 and pi.